All right, so one of the new exciting features you may have heard about that just was released is the highly anticipated feature request for load balancing. Up until this point, when it applies to the relay bindings, you would likely encounter a very unfortunate exception when you tried to start more than one listener using any of the net or the relay bindings. Excuse me. You'd get a all address already in use exception. So on the 26th, saw a tweet that was circulated throughout the community from Valeri, who's a member of the Azure customer advisory team, indicating that load balancing was done. And following that, there were a couple of good posts within the community. One from Sam, indicating that the next day that feature was in fact rolled out to data centers throughout the U.S. And it appears that the feature first found its way in Asia. Richard Seroder, posted a nice, succinct overview of the new feature and kind of indicated that he may have been using another region. I started testing this that same day, and unfortunately was not able to see that new feature in action. However, as of today, in the south central U.S., which is where my Azure Service Buses account is based out of, the feature is working as expected. So I'd like to quickly walk you through what that looks like. So here is a nice TCP, net TCP relay binding-based sample provided by Microsoft, largely unaltered. It consists of a very simple service contract that will basically take a name in a one-way context, and then basically what I do is write that to the console to show that the message has in fact been received. Nothing really else going on here. Very simple boilerplate WCF hosting. In fact, this was a 1.0 service bus sample that I've now updated to the 1.5 version of the Microsoft Service Bus assembly. The easiest way to get your hands on this new assembly is to basically grab the NuGet package. So you'll notice here that it's installed both for my service project as well as my client. And my client project is actually a little bit more interesting. It's basically using a channel factory here to send a series of messages in a loop. And then it actually also tries to upgrade the connection to direct, which is kind of a nice feature that the NetTCP relay binding provides, which is why Microsoft generally recommends NetTCP relay unless you have specific needs for one-way or datagram messaging. So with that, what I'm going to do is actually pop into the folder that the executable resides in, so I can actually create a number of different instances. And so I'll start with the first one, entering my service bus namespace name, and just verify that that is running. Most of you watching this are probably already familiar with the capabilities of Relay, but I'll just point out that I'm running this this little demo here out of my home office that happens to run on Cox cable, right? So I'm exposing a service on my laptop sitting in my home office that's literally callable by anyone in the world, provided they have an internet connection. So I've got one instance up and running. I'm going to go ahead and start the second instance, and this is what was just not possible before. There was a couple workarounds. There was a sample that I believe Clemens Vassars put together that showed how to do the round tripping or the round robin on the client side. but that wasn't palatable to a lot of customers, including customers that I've worked with directly, for some good reasons. So it was a decent workaround, but it's really nice, as you can see now, that the load balancing support is in fact there, and there's literally nothing I had to do on the code side other than update the client to the 1.5 client. So let's actually, just for grins, let's go ahead and create another service listener, and then we'll go ahead and run the client, which will pump a number of messages to one of these instances. Great. So I'll go ahead and run my client now. Let me just bring these into the screen here. Now, one of the things that you will notice is that there really is no way to drive the client to a particular service instance. So there's some documentation that indicates that it's pretty much random. And as you can see here, the service instance at the top just happened to receive the messages. So pretty significant feature. I know that there's a lot of customers that have been clamoring for this, and as you can see, it pretty much works exactly as expected. Thanks.